Okay, today we are discussing Unit 12, Numerical Integration 2. Numerical Unit 12. Unit 12, Numerical Integration 2. Numerical Integration. Numerical Integration. Page number 247. So, Simpson's 3 by 8 rule. How to derive Simpson's. Yesterday, what we discussed about trapezoidal and Simpson's 1/3. Today, Simpson's 3 by 8 rule. Simpson's 3 by 8 rule. 3 by 8 rule. Simpson's 3 by 8 rule. Recall the general quadrature formula. Derivation proof. So recall the quadrature formula, Newton-Cotes quadrature formula. That is integration x naught to xn, x naught to xn, f of x dx, f of x dx, that equal to f of x dx equal to integration x naught to x naught plus nh, x naught plus nh plus nh, f of x dx, f of x dx, that equal to h ny naught plus n square by 2 delta y naught plus n square by 2 delta y naught plus 1 by 2 n cube by 3 minus n square by 2 n cube by 3 minus n square by 2 n square by 2 delta square y naught delta square y naught delta square plus 1 by 6 n power 4 by n power 4 divided by 4 n power 4 divided by 4 minus n cube plus n square delta cube y naught delta cube plus 1 plus 1. This is known as Newton's Cotes quadrature formula. In this formula, put n equal to 3 by putting n equal to 3. The general quadrature formula 1. Then all differences of fourth and higher order becomes 0. Fourth and higher order. Proceeding Simpson's 1/3 rule. No, to get, we obtain, we obtain, we obtain, we obtain. Okay. Integration x naught to xn, f of x dx, f of x dx, f of x dx, that equal to integration x naught to x naught to x naught plus 2h, x naught plus 2h, x naught plus 2h, f of x dx equal to f of x dx, f of x dx equal to h, h 3y naught, 3y naught plus 9 by 2 delta y naught plus 9 by 2 delta y naught, delta y naught plus 1 by 2, 1 by 2. 27 by 3 minus 9 by 2, 27 by 3, 27 by 3 minus 9 by 2, 9 by 2. Delta square y naught, delta square y naught plus 1 by 6, 81 by 4, 81 by 4, 81 by 4 minus 27, minus 27, minus 27 plus 9, plus 9, plus 9. Delta cube y naught, delta cube y naught, delta cube y naught. That equal to h, h 3y naught, 3y naught plus 9 by 2, 9 by 2, y1 minus y naught, y1 minus y naught plus 9 by 4, 9 by 4 plus 9 by 4, y2 minus 2y1, y2 minus 2y1, y2 minus 2y1 plus y naught, plus y naught plus 3 by 8, 3 by 8 plus 3 by 8, y1 minus 3 by 2, y1 minus 3y2 minus 3y2 plus 3y1, 3y1 minus y naught, y naught. That equal to that equal to 3h by 8, 3h by 8, 3h divided by 8, 3h by 8, 3h by 8, 8y naught, 8y naught plus 12 y1 minus y0 1 y1 minus y0 12 y1 minus y0 plus 6 y2 minus 2y1 y2 minus 2y1 y2 minus 2y1 plus y0 plus y0 plus y3 minus 3y2 y3 minus 3y2 3y2 minus y0 yes y0. Next 3h by 8. On simplification, we obtain y0 plus 3y1 plus 3y2 plus y3 plus y3. Similarly, similarly, integration x0 to xn f of x dx f of x dx f of x dx integration x0 plus 3h x0 plus 3h x0 plus 6h x0 plus 6h f of x dx f of x dx that equal to 3h by 8 3h by 8 3h by 8 3h by 8 y1 plus 3y4 y1 plus 3y4 plus 3 3y1 3y4 plus 3y5 3y5 plus y6 y6 plus y6 so 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 on finally integration finally integration xn minus 2 xn minus 2 to xn f of x dx equal to f of x dx that equal to integration xn plus n minus 3h n minus 3h to xn plus nh xn plus nh f of x dx equal to f of x dx f of x dx equal to 3h by 8 3h by 8 3h by 8 yn minus 3 yn minus 3 yn minus 3 plus yn minus 2 plus 3 yn minus 2 n minus 2 plus 3 yn minus 1 n minus 1 plus yn. Assuming n is multiple of 3. Assuming assuming n is multiple of 3. N is multiple of 3. Multiple of 3. Multiple of 3. Assuming multiple of 3. Assuming multiple of 3. So adding all these n integrals we obtain. Adding 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 all these adding all these n integrals, all these n integrals, all these n integrals n integrals we obtain means we get integration x to integration x naught to x naught plus n f of x dx f of x dx that equal to f of x dx f of x dx that equal to integration x naught to x naught to xn plus 2h x n plus 2h f of x dx f of x dx that equal to dx of x dx plus dx plus integration x naught to 3h integration x naught plus 3h x naught plus 4h x naught plus 4h naught plus 2h 6h f of x dx of x dx plus 4 plus x naught plus n minus 3h minus 3h x naught plus nh f of x dx f of x dx. Okay. That equal to 3h, that equal to 3h by 8, 3h by 8, 3h by 8, y naught plus 3y1, 3y2, 3y1 plus 3y2, 3y1 plus 3y2, 3y1 plus 3y2 plus y3 plus y3 hmm, y3 plus y3 plus 3y4, y3 plus 3y4, y3 plus 3y4, 3y4, y3 plus 3y4, 3y5 plus y6, 3y5 plus y6 plus so on plus yn minus 3, yn minus 3 plus 3n minus 2 plus 3yn minus 2 minus 2 plus 3yn minus 1 yn minus 1 3yn minus 1 plus yn integration x naught to xn x naught to xn f of x dx f of x dx 3h by 8, 3h by 8, 3h by 8, y naught plus yn, y naught plus yn, yn plus 3 into y1 plus y2, y1 plus y2 plus y4, y4 plus y5 plus y5, y5, y5 plus so on, yn minus 2, yn minus 1 plus yn minus 2, yn minus 2 plus yn minus 1, yn minus 1 plus 2 into y3, y6, y9, y3 plus y6 plus y9, y9 plus so on plus yn minus 1 plus yn minus 3 minus 3. Yn minus 3. Yn minus 3. This is called Simpson's 3 by 8 rule. Simpson's 3 by 8 rule. So just note is there. Note. In deriving the formula, the function f of x is approximated by note. In deriving this formula, in deriving this formula, this formula, this formula, f of x is approximated by f of x is approximated by f of x is approximated by cubic polynomial, cubic polynomial, cubic polynomial, which passes through 4 consecutive points, which passes through 4 consecutive points. Consecutive means following numbers, following points. Consecutive points. PTS means points. Second one. Simpson's 3 by 8 rule can be applied. Simpson's 3 by 8 rule can be applied. Simpson's rule, 3 by 8 rule can be applied only when the given interval interval when the given interval a comma b is divided into a comma b is divided into a number of equal subintervals, number of equal subintervals which must be multiple of 3, which must be multiple of 3. Multiple of 3. Multiple of 3. Third one. In majority of cases, the results obtained by majority of cases, majority of cases, majority of cases, the result obtained by result obtained by obtained by applying Simpson's 3 by 8 rule. By applying Simpson's 3 by 8 rule. Simpson's 3 by 8 rule. Rule is found to be less accurate. Is found to be is found to be less accurate. Less accurate. Then Simpson's 1/3 rule. Then Simpson's 1/3 rule. 1/3 rule. 1/3 rule. Simpson's 1/3 rule. Simpson's 1/3. Okay, using this result will solve one problem. Example 1. Example 1. Evaluate integration 0 to pi by 2, 0 to pi by 2, 0 to pi by 2, to pi by 2, by 2. E power sin x dx, e power sin x dx, e power sin x dx. Correct to 4 decimal places. Correct to 4 decimal places. This is 4 decimal places. Using Simpson's 3 by 8 rule. Simpson's 3 by 8 rule. 3 by 8 rule. Choosing 3 subintervals. Choosing 3 subintervals. 3 subintervals. This is the question. Solution. Solution. So here, let y equal to f of x, y equal to f of x, y equal to f of x, that equal to y equal to f of x, that equal to e power sin x, e power sin x. Here, lower limit, a equal to 0. A means lower limit, a equal to 0. B means upper limit, is pi by 2, is pi by 2. And n equal to, 3 subintervals is given. Then h we need to find. H equal to, what we have? What is h? Subintervals, width of the subintervals. Width of the subintervals. H equal to b minus a whole divided by n. That implies h equal to b means pi by 2 minus 0 whole divided by 3. That equal to pi by 6. Equal to pi by 6. The values of the function y equal to values of the function, values of the function, values of the function y equal to f of x, y equal to f of x, equal to f of x, with h equal to pi by 6 are tabulated here under. H equal to pi by 6 tabulated. That means x 0 pi by 6. Next pi by 3, pi by 3, pi by 3. Next pi by 2, pi by 2. So then y equal to f of x, that equal to 1 and 0, e power 0, so e power sin 0 is 1. Next, 30, 1.6487, 6487, 6487, 648, 2.3774, 2.3774, 2.71, 2.7183, 7183. By Simpson's 3 by 8 rule. By Simpson's Simpson's 3 by 8 rule. 3 by 8 rule. Simpson's 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 3 by 8. Integration x naught to xn. Integration x naught to xn. F of x dx. F of x dx. F of x dx. That equal to 3h by 8. 3h by 8. 3h by 8. Y0 plus Y3. Y0 plus Y3 plus 3 into plus 3 into Y1 plus Y2. Y1 plus Y2. Y1 plus Y2. Then we need to substitute integration. Therefore, integration 0 to pi by 2 e power sin x dx, that equal to 3 into h by 2, 3 by 8 into h means pi by what 3 pi by so x values. How do you got x values means f of x equal to what is there? E power sin x. Understood? Then we need to substitute. First one is 0. Substitute f of 0 e power sin 0. Sin 0 is e power 0. E power 0 is 1. Understood? Next, second one. Suppose second what is there? Pi by 6. This is rough work. Pi by 6 is equal to pi by 6. Substitute pi by 6. Pi by 6. That equal to e power sin pi by 6. Pi by 6 means sin 30 degree. Sin 30 degree is 1 by 2. E power 1 by 2. From scientific calculator, E value is 2.718. So from scientific calculator, you have to substitute 2.718 whole power half. From scientific calculator, you will get the value. What is that? 1.6484. Understood? Next, 3 by 8. Rest of all like that only. 3 by 8. 5 by 6. 5 by 6. 5 by 6. 1 plus 2.7183. 7183 plus 3 into 1.6487 plus 2.3774. On simplification, we obtain 3.1017 approximately. Approx means approximately. Okay. Next. Most important rule is Weddell's rule. So Weddell's rule. Weddell's rule. 1 point. Weddell. Weddell's rule. Put n equal to 6. Put n equal to 6. 6. We obtain Weddell's rule. we get Weddell's rule. Weddell's rule. Weddell's rule. Derivation, do it as homework. Based upon Weddell's rule, write Weddell's rule. 3h by 10. That equal to derivation, homework will do it. I will write and we'll do one sum. 3h by 10. 3h by 10. Y0 plus 5y1. Y0 plus 5y1. 5y1 plus y2 plus y2 plus 6y3. 6y3. 6y3 plus y4. 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 Y4 plus 5y5. 5y5. 5y5 plus 2y6. 2y6 plus 2y6 plus 5y7. Y7 plus 5y8. Y8 plus so on. Note. 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 Note by note. Application of Petal's rule requires at least 7 consecutive. Application of application of application of Petal's rule. Petal's rule. At least 7 consecutive values of the function. At least 7 consecutive values of function. Values of function. Values of function. Values of the. Here the function is approximated by polynomial of 6th degree, which passes through 7 consecutive points. Hence f of x is a polynomial degree of less than 6. Weddell's rule gives the exact value of the integral. Weddell's rule. This rule gives the exact value of the integral. The integral of the integral of the integral. Next, Weddell rules can be applied only when the given a comma b divided in a number of equal subintervals which are multiple of 6. Weddell's rule. This rule can be applied can be applied when the given interval a comma b, closed interval a comma b, closed interval a comma b is divided into a number of is divided into a number of equal subintervals equal subintervals number of subintervals which must be multiple of 6, which must be multiple of multiple of 6. So generally Veda's rule gives the more results than other rules. So generally Veda's rule gives the this rule gives the this rule gives the gives us more accurate result, more accurate results than other rules. Other rules. So using this rule, we'll solve some example 2. Page number 253. Page number 253. Evaluate integration 4 to 5.2 log x base e dx by using Vedal rules. By using Vedal's rule. By using Vedal's rule. Compute with its exact value. Compute with its exact value. Exact value. Solution. Here at y equal to f of x equal to of x equal to log x base e. Log x base e. A equal to 4, b equal to 5.2, n equal to n equal to n equal to 6, n equal to 6, n equal to 6, because 0 to 6 means 7 values, exact 7. So h equal to b minus a by n. That implies h equal to 5.2 minus 4 whole divided by 6. That equal to 1.2 divided by 6. That equal to 0.2. 0.2. So the values of function y equal to f of x, each point subdivided h equal to 0.2. So x, table x. So first one, 4 means 4.0. Next 4.2, 4.2. Next 4.4, 4.4. Next 4.6, 4.6, 4.8, 4.8, 5.0, 5.0,